Dear friends, in this video lecture, we are going to discuss about the transmission impairments. How the impairments happen while transmit the signals. What are the causes are there that we are going to discuss in this video. In the unit 1, under classroom discussion topic, we are going to discuss about transmission impairments. So after listening to this video lecture, what is the outcome of this video that we are going to discuss now? After listening to this video lecture, as a students, you will identify the impairments of signal transmission and identify the causes of the signal impairments. So first, transmission impairments. What is transmission impairments? Signals travels through transmission medium which are not perfect. That means imperfection causes signal impairments. If I am sending one signal, same signals I received in the destination are not. Okay. So if received the same signal, there is no impairment. If received in a different signal, there is a impairment. Okay. So how it is happened? What are the causes are there? That we are going to discuss in this video lecture. This means that the signal at the beginning of the medium is not same as the signal at the end of the medium. Now I said yes. Sender is sending some signal, receiver is receiving different signals. Okay, with some disturbance or noise, something that we are going to discuss here. So what is sent is not what is received. Three causes of impairments are there. What are the things? First one, attenuation. Second one, distortion. Third one, noise. These three factors are main causes for impairments of the signal. First one, attenuation. What is attenuation? Attenuation means a lot of energy. Okay, loss of energy. If energy of the signal is there, no, that will be reduced or some losses may be there. That losses of the energy is called like attenuation. Clear? When a signal, it may be simple signal or composite signal, it is not a matter. While travel through a medium, it lost some of its energy in overcoming the resistance of the medium. Okay, resistance of the medium, it may be increased. Due to that, signal may be lost. That's why a wire carrying electrical signals get warms, if not hot, after a while. Some of the electrical energy in the signal is converted to the heat. What we are saying, continuously we are sending the data signal in the transmission medium. While transmitting, it will generate the heat. Okay. So because of that heat, the data may be lost. So how to compensate this loss? Then again we will go for amplifying the signal. That's why we are using amplifier. Amplifier is amplifying the signal which is already lost in the cable. So see this diagram. This diagram simply we can represent how the signals are transmitted, that we are going to see here. So initially we are sending the signals like this. Okay. So we are sending signals like this in point 1. While transmitting the signal in this medium, this transmission medium, this link, it may be reduced the signal energy. Okay, here the energy is like this. Here the energy is like this. So entirely the signal got some losses in this signal at this point. So what I'm going to do, so I want to get the original signal. Then for that purpose, I'm using the amplifier. The amplifier amplifying the energy of the signal. Okay. So this loss of energy is there, no? How much energy is losses? That is considered as the attenuation. Okay. So normally, loss or gain of the energy may be represented in the unit of decibel. Okay. So decibel normally we can write dB. So what is the formula we are going to calculate for decibels? Decibel means loss or gain of the energy. Okay. So 10 log 10 P2 P1. What is P2? P2 is the output signal. P1 is the input signal. Okay. So how we can write it? 10 log of P2 output signal by P1 input signal. Okay. So this is the formula we are going to apply for calculating the attenuation. Clear? So now you can see here, okay, what is happened. Suppose a signal travels through a transmission medium and its power is reduced to 1/2. Okay. So what they are saying that we are sending some signal with the energy level. That energy will be reduced in half. Okay. So then what is the attenuation? How we can calculate the loss of power or loss of energy? So we can apply the formula. Okay, here. How we can apply it? So we know that half of the energy only it is received. Okay, so output signal is half of the input signal. So what is the formula we have to use? Decibel equal to, normally the loss of energy may be calculated using the decibel, then log of P2 value. What is the P2 value? Example P2 will give P2. So P2 equal to half P1. Normally formula is P2 by B1 log 10. So here 10 log of P2 value is 0.5 P1. Okay, divided by P1. So here it is forward. What is the value? 10 log of 0.5. What is the 0.5 value? Log 0.5 value. So 10 into minus 3. Minus 3 is the 0 point value. Log of 0.5 value. So finally, what is the value? Minus. If you are multiplying it, 3. Okay, so 0.3. Sorry. Log of 0.5 value is minus 0.3. Okay, so while we are multiplying it, 3 will come, minus 3. So answer is minus 3 decibel. So what is the loss? Minus 3 decibels. Minus means minus represent the loss of the energy. If you represent plus means that is gain of the energy. Okay, so what they are saying that while using this amplifier, the power is increased 10 times. Okay, what is the amplification? That is the gain of the power. So what it will be happen? Okay, so whatever it may be, P2 is 10 of P1 by P1. So 10 times it is over. So what is the value? 10 into 1. So 10 decibels it is increased. Okay. So distortion. What is distortion? Distortions means that the signal changes from form. That whatever we are sending, that form will be changed. Form of the signals. Okay. So we are sending like this. Then the signals may be sent like this. Some changes in the signal or shape of the signal will be changed. Distortion can occur in composite signal made of different frequencies. Okay, how it will be changed? So composite signal means many signals transmitted at a time. Each signal component has its own propagation speed. Okay, so different signals will be transmitted with different propagation speed. Okay, so through a medium, and therefore its own delay it's arriving at the final destination. The differences in delay may create the differences in phase. The delay is not exactly the same at the period duration. In other words, how we can say this? Signal components at the receiver have phases different from what they had at the center. Okay, so how the phase will be there? So I already told, it will start from 0. For example, in the center side, that receiver side, what will be happen? Some delay, some shape will be changed, so automatically it will comes like this. 90 degree it will enter in the 0 time. Okay, so in the receiver place. So that is the distortion. So here you see this is a composite signal with different signals we are merged and we are sending this signal to here. Okay, but what happened after receiving this side? Okay, this receiving side, the shape of the composite signal may be varied. Okay, so after receiving side, it may be varied. So that this is called like distortion. The third point is noise. What is noise? Noise is another cause of impairments. Okay, so several types of noises are there. So here that is mentioned here, thermal noises, okay, and induced noise, crosstalks, and impulse noise may corrupt the signal. So these are the different types of noises may be affected the signal. Because of that, the noise will be added with the signal. So what is thermal noise? Thermal noise means a random motion of electrons in the wire. Okay, so some extra electrons may be transmitted in the medium, which creates an extra signals. Okay, that will be not originally sent by the transmitter. Automatically it's generated and it will be added with the original signals. That is the noise, thermal noise. Induced noise. What is induced noise? It is comes from source such as motors and appliances. Okay, so the sensor is receiving some motor data. While it's recording it, it's getting affected some vibrations of motors or sounds of the motors or something. So that is called like induced noises. And crosstalk, already we know that crosstalk means somebody's are some voices will be mixed with us. It will be crossed. These devices act as a sending antenna and this transmission medium act as a receiving antenna. In induced noise may be different. So crosstalk means, what is a crosstalk? Is the effect of one wire on the other. Okay, so if we are keeping more wires on wire, then it will be happen. So here you will see that this is the originally transmitted signal. So after adding the noise, okay, so noise may be a different form. It both will be added and finally it will generate like this. So the signal added with noise and it is reached to the point 2. Okay. So now we are going to discuss about signals to noise ratio. Signals to noise ratio, SNR. Okay. So you just remind that it will be useful for you. Okay. So we know that bitrate rate, we know that the ratio of the signals power to noise. What is that SNR? SNR means average signal power divided by average noise power. Okay, what is the original signal? Signal power and what are the noise added in that? That will be calculated under the SNR. Okay, we need to consider the average signal power and the average noise power because they may change with the time. Okay, so we don't know what is this exact value. That's why we will take the average. Okay, SNR is actually the ratio of what is wanted, what is not wanted. Okay, so what is wanted means signals. Normally we are sending the signal, that is we record. So what is not wanted, noise is not required. So this ratio is considered SNR. Okay. So high SNR means that signal is less corrupted by noise. High SNR means noise is very less. Low SNR means more voice. Okay, it is corrupted with the noise. Because SNR is the ratio of two powers. It is often described in decibel units. Normally we are representing SNR also in decibel units. SNR decibel equal to 10 log 10 SNR, signal rise noise ratio. Okay. So two cases of SNR, high SNR, low SNR. What is high SNR? High SNR means low noise. Low SNR means high noise. So noise is less. So it is signal is getting very less. So high SNR means large SNR means it is very less. But here small SNR. Okay, what will be happen? More disturbance are there. Okay. So this diagram is represented like this. So now you can see lecture learning outcomes. So end of this lecture, you can identify the impairments of signal. So you know how the signals are impairments are there are not in the signals. Even if it is there means what type of causes are there for making these impairments. Like you know very well what are the different causes for making the impairments of the signals. So now we will discuss about small questions. So now we will see just sample questions. So you read this question. If the signal at the beginning of the cable with minus 0.3 decibels. So normally we are saying that energy or power of the cable like this, how much length of the cable also we have to calculate. Okay, so 5 kilometers we want to calculate the power of the signal at the 5 kilometers. So minus 1.5 decibel. So after that, what is that? 2 milliwatts. The power is 2 milliwatts. They are given. So finally, what we have to do? We have to find the what is the power of the signal. So power we can how we can calculate? Power we can calculate is decibel equal to 10 log 10 of here. What is the P2 by P1? What is the output value? What is the input value? So finally, this value, what is the value they are given? Minus 1.5. How it is? Minus 1.5. So this total values are minus 1.5. We are calculated. This is the value we are receiving. So now we will calculate that P2 by P1. So what is the P2 by P1? This is 10 power minus 0.15. Okay. So what is this value? 0.71. So P2 equal to 0.71 P1. Okay. So what is the value? Now we have to calculate 0.7 into 2 milliwatts. Okay. So totally 1.4 milliwatts. So this is the power which is while transmitting the signal with the 5 kilometers of length. Okay. The second example, just to see this, the power of the signal is 10 milliwatts and the power of the noise is 1 microwatts. Okay. So what is the SNR? What is the SNR decibel? So first one, what is the formula we have to write? SNR equal to first difference between the power of the signal and power of the noise. So noise they are given in the microwatts. Okay, 1 microwatts. 1 microwatts means 1 into 10 power micro. Micro means minus 6 watts. Okay, so here power value, what is that? 10 milliwatts. We can convert 10 milliwatts into microwatts. So how we can convert it? Already 10 into microwatts means what we have to do? We have to multiply with thousands. Okay. So already this value is there. When we are converting into the microwatts, it will be 10,000. 10,000 microwatts because already 10 power 3 is there. Again, we have to multiply with 10 power minus 3 means 10 power 6. So 10,000 microwatts. So here 10,000 is there and divided by 1 microwatts. So finally the value is 10,000. Okay. So this is the SNR. SNR decibel, what is the answer? SNR decibel. So again, P2 by P1 value we have to calculate it. So what we have to calculate it? 10 log P2 by P1 of 10. So 10 into what is the log? 10 value log of here 10,000 is there. 10 power 4 is there. Okay. So here 10. So 10 into 4, totally 40 decibels. So like this we can find the value. So now we are in end of this lecture. Thank you very much for listening. The next classroom discussion topic is guided media. We will discuss in the next video lecture about guided media. Thank you all.